We're going to do a little introduction to elements and the parts of the atom that make up each of the elements. So we're going to kind of go through this one at a time and make it a little bit harder as we go. So I want to do the first one with you and then have you try them and ask you to try to stop the video and try it yourself. So as we look at your periodic table, that'll tell us a lot of what we are trying to figure out here. So the atomic number, as you see it labeled, is a 2. That tells us, no matter what, for sure, there are 2 protons. Even if that was an ion or a different isotope of helium somehow, that is the identifying factor. So these 2, no matter what, would have to be the same number. That is a for sure, no matter what. The atomic mass, if I look in the periodic table, is 4.00. We're going to use that because that will be our rounded how many, we'll figure out, calculate where that atomic mass comes from later. But if we round that to the nearest whole number, in this case obviously it's a 4, that'll tell us how many things are in the nucleus. That's a whole number because it is how many actual protons and neutrons are in the nucleus. So since there's 2 protons no matter what, because it is helium, there is going to be 2 neutrons in this case. Because there's 4 total things in a nucleus, and these guys are in a nucleus together. What about the electrons? Well, the protons are positive, the electrons are negative, and since there's no charge here, it's not an ion, that indicates that it's an atom. That means that there's equal amounts of protons and electrons. So I want you to try one yourself, and it is a very exciting element called boron. Find that on your periodic table, stop the video, and try it yourself. All right, we're back, so I'm going to go ahead and fill in these things. The atomic number is 5, atomic mass is 10.81, so in this case we're going to assume that there's 11 things in a nucleus. That doesn't mean that there always is, but the most typical boron atom would have 11 protons and neutrons together. Since the atomic number is 5, the protons have to be 5. These 2 columns, again, have to be for sure the same. I don't see a charge here, so I'm going to go ahead and put the electrons in as 5. The neutrons, since I have 11 total things, would be 6, because 6 plus 5 is equal to 11. All right, so we'll try something different now. Fluorine with a -1 charge. So I'll go ahead and do this for you real quick. It is atomic number 9. 19.00 is its atomic mass. That means that the mass number, typically there's 19 things in a nucleus. The atomic number is 9, so that means protons are 9 for sure. The neutrons are going to be 10 in this case, and now is where that ion charge comes into play. Because it's a -1 charge, it means there's one more negative electron in this type of atom. It is now called an ion instead of an atom, actually, once that is unbalanced. So now that there's one more electron, it means there's 10. So I want you to try one of those yourself. It's calcium with a 2 plus or a +2 charge. I'm going to ask you to pause the video and just give it a whirl. And push play again once you're done and check it. All right, so we're back. We'll fill it in. 20, 40.08, 40, protons are 20, neutrons are 20. Now, however, it is a 2 plus charge, so that means there's 2 more positive protons. This 20 can't change. So if you wanted to say, well, then it's just 22 protons because it's a positive 2. No, if it was 22 protons, that'd be titanium. So the calcium means that there's 20 protons for sure no matter what. So the electrons are what could change. So if I have 18 electrons, that means there's 2 more protons than there are electrons. So I have a +2 charge because of that. All right, we're going to do 2 more. Next one is carbon 14. This is called a hyphen notation. And what this 14 is automatically indicating the mass number of this atom. It is not the typical atom of carbon because, as you can see on your periodic table, the typical atom of carbon would be carbon 12, which is most of the carbon that makes us up. But some of us is carbon 14, a very small amount of it. This is going to be a 6. But this 12.01, you always take the same. The atomic mass you pull from the periodic table will just be for sure. But Once we see this after the hyphen, that means that this is a special isotope. Now, if I would say, hey, carbon 12, well, that would be the most typical isotope. It would still be written this way, however. So just because I wrote it carbon 14 or C-14 doesn't mean it is not the most typical, but in this case, it is not. This is what the isotope that's used in carbon dating to figure out how old a fossil is. So the protons are 6 no matter what. I don't have a charge up here. I could. I don't have a charge up here, so the electrons are 6 also because equal positives and negatives. But in this case, with this specific isotope, there'd be 8 neutrons because of the 14 for the mass number in this situation. Another way of writing that would be like this, carbon 14 over 6. That's called a nuclear symbol, where the mass number is on top, the atomic number is on bottom. Let's try one more of those. I want to write it here both ways. U-235, or we could do the nuclear symbol, 235 over 92. So if I go through this, 92, this is 92 for sure. The atomic mass is from the periodic table. That would be 238 on our periodic tables. But this is a mass number, a special isotope, 235. This isotope is the isotope that's used in nuclear weapons because it has the ability to break apart or to fission and produce energy. 238 does not. The electrons will be the same, but the neutrons will be the 235 minus the 92, which I believe is 143. I'm hoping that oops, that's a 3. 143. Let me think.